East for setting up new business in diamond cutting technologies. Decotech LLC Dubai for setting up diamond cutting technologies business in UAE. Retained as demolition consultant for demolition of MG Setu, India's longest bridge over Ganges in Patna. Project executed by Afghan's infrastructure demolition contractor Edifice Engineering Mumbai. Demolition consultant of Edifice Engineering Mumbai for Maradu building implosions in Kochi. He is also a member of expert committee appointed by High Court of Chennai for structural soundness investigation of an 8-storied building in Chennai, and member of PUSHEP Paikara Upper Stage Hydroelectric Project Committee of Tamil Nadu Electricity Board, and also a member of Corporate Advisor Board CAB, Department of Civil Engineering, SRM University, Chennai. He has published a good number of papers in various journals and conferences. Especially, he had brought up some technologies to India like the use of modern equipment for concrete flatwork construction such as power trowels, truss screeds and joint saws. The concept of diamond cutting technology for construction in India, the art of controlled demolition of structures using collapse analysis by explosives, the technique of DPC in India for infocom sector, the use of hydraulic concrete crusher for silent demolition of structures in India in November 2006, and introduced a new construction technique for mini trenching in concrete pavements at Dial for Larsen L&T Company Limited. This unique method was reported in German magazine BAU magazine in February 2008 edition.
Nagabharat, excuse me, your voice is breaking, so a lot of noise we are getting. So
just a second, sir.
Still we are getting lot of noise. So I request you kindly stop, so that the lecture will continue, because we are getting a lot of noise. So thank you, Mr. Bharat. Now okay. I request. Sorry, sir. Now I request Mohan Ramanathan sir, kindly start the lecture. So thank you, Mr. Bharat. So, sir, Mohan Ramanathan sir, kindly unmute. Sorry.
Good morning to you all. I hope I'm audible.
Now still black bar is there, sir.
No, the black bar is gone.
No, sir. Here it is showing. So now it has gone, sir. Okay, sir. Now we can start. It is fine, sir. Now.
So again, good morning to you all. Sorry for about the little hiccup and delay. I wish to thank IGS Guntur chapter, Professor Ramarao, and the student chapter of the college for giving me this platform to share something very important to India. So you must have had in this same platform almost every day. They're doing a wonderful job of bringing technology to your home by way of these series of lectures. So you heard a lot of academicians, you heard a lot of research scholars, you heard people from the industry, from government organizations, so on. Now, what I'm going to give you is something very thought-provoking and what is necessary for India in the geotechnical field. Sir Ramarao, am I audible clearly?
Sir, yes, sir, it is clear.
Okay. So this presentation is all about what can the equipment industry, heavy earth moving industry do for the geotechnical engineering or ground engineering community in India. It is a well-proven fact that geotechnical industry depends entirely or very large percentage of the work done is using equipment. I just want to throw open the opportunities available in India in line with our Prime Minister Modi's programs of Make in India. And there's going to be thought-provoking, a lot of message I'm going to get through. I have professionals in this audience. I have students who are future of India. We have academicians and equipment manufacturers. So let me proceed. First of all, let me, for want of time, for fear of want of time, usually this is my last slide, but I'm putting it as the first slide. So many people and many more have contributed, or I borrowed pictures or videos from many of these organizations who are in some way connected with ground engineering. And I also thank my alma mater, IIT Madras, and my university in the US, Urbana-Champaign, for giving me this knowledge till date. So a little about one slide about what my company is doing. I'm Managing Director of Advanced Construction Technologies, as you see, ACT. This is a company I formed 35 years ago, and we have 3 sister companies today, and under them, Pack Power Solutions. So what do? We represent these big names below: Volvo, Atlas Copco, Epiroc, Linde, Volvo Penta, Liebherr, Wacker Neuson, SDLG, Primex, Bowmanet. All these are connected with construction. All these are companies which we are dealers or service providers, or they are knowledge partners in some way or the other. And the area of activity of my company, ACT, based in Chennai, is, as you see on the right side. I'm not reading all these things. So we are in all these spaces, and in the last 35 years, we have touched most of these areas where construction and infrastructure is involved. So with this background, we'll jump into the actual lecture. My presentation outline is statistics on earth-moving machines. So those of you students and the academicians who may not know what is the strength of earth-moving machinery in India, the population, and who are the manufacturers, I'm going to give you a glimpse of it. Why ground engineering is important to India at this stage, and why is it important to the stakeholders, and what are the possible areas of engagement of these manufacturers to bring technology into the construction, into the ground engineering construction segment. What are the present methods and machines available across the world? I'm not talking about what's being done in India, across the world. In the next 10 years, all of this will come to India one way or the other. How to engage our entrepreneurs, you youngsters? How do you come into this line? How do existing contractors learn from this? How about the technical experts in the field, the consultants, the academia? How can they help? What action points we should learn from today? And conclusion. As all of you know, or most of you will know, ground engineering has been there for 2,000 years. The Romans have built the first piles, wooden piles, way back 2,000 years ago, and they had some contraption to drive the piles. So these are small sketches from the old textbooks. You can find them. They're all piling machines, some way to drive the piles under the ground. So that's where the inception of the concept of driven piles came from. You can go to Chelly's book. You can see some more pictures, so it's nothing new. What's new is the new technology, new manufacturing technology we can use to improve on this. Now, what about India? Who are the equipment players in India? So India has so many manufacturing brands, or at least representation brands in these 3 sectors. For the students, I'm saying the earth-moving equipment is divided into 3 sectors, 3 distinct segments. One is called the mini segments, which we have many. It's first of all, you should know it's classified by the weight of the machine. So what we call as the mini excavators and skid steer loaders, SSL. So we have almost 20 manufacturers or 20 brands that are working in India. Some are imported, some are manufactured in India. So you see the brands. They're all part of today Indian industry. The backhoe loaders, or generically we call it as the brand JCB, but basically they are called backhoe loaders. BHL is the terminology, and more famous and more made very popular by the company JCB. But we know there are so many other brands. As you can see, there are 12 brands of backhoe loaders as a choice, and at least 10 of them manufactured in India. And so this is India is the largest market in the world for backhoe loaders. Then come to the excavators. So we have so many brands of excavators in India. these, most of them are manufactured here. Some of them, the bigger ones, 120 tons, may not be manufactured here. Some of them import. So these brands are all present here. In all, there are 33 manufacturing plants across manufacturing brands. Each brand may have more than one factory, contributing to the Indian construction industry, construction and mining industry. So India sells about 70,000 units of all these machines put together. These three classes of machines put together, annual sales is 70,000. And you know, these machines, when they get old, about 10 years later, it is scrapped. So there are working units. If you look at how many units are actually working, is 380,000 units of these combination of these machines are working in India. So even if you have 1% of this concentrated to do in the ground engineering industry, that will be a lot, like 3,800 machines. If you convert them to ground engineering applications, we will go leaps and bounds in this, in our geotechnical field. Now let's take the case of the most popular equipment in India, which is called the hydraulic piling rig. All of you know about this. So if you see who are the manufacturers who are selling in India, you see the names on the left. All these are not Indian. All these companies have been selling this equipment in India, and all of you know India has a we have to sell, we have to buy through foreign exchange, we have to pay high customs duty. So this raises the entire cost of piling. So I'm not saying these equipment are bad, they're very good. It's a quick way to catch up, but now is the time that our manufacturers should wake up to this demand. So my question is, why no Indian manufacturers in piling in India? It's not rocket science. They're all based on excavators. We have 33 manufacturers in India. This is just a question I'm posing. So that today we have 2,000 units of these manufacturers imported working in India. Our demand is very high, and more people will get in if the price barrier is broken. There's one company in Tamil Nadu, which PRD, which makes small drilling rigs. They're not the hydraulic piling rigs, but they make small drilling rigs for soil nailing and so forth. My appeal to this august audience and the students is take advantage of the government programs, and we should make these attachments with the help of manufacturers. And ground engineering. Our ground engineering has touched us in so many ways. I borrowed this from Hayward Baker posters. You can see everything below the ground is ground engineering. So much possibilities, so much, and everything depends on equipment. Without an equipment, what you see cannot be done. Today we have so much underground work about so many metro projects, all underground, the stations, underground tube tunneling. So there's so much work going on underground, and without equipment, it cannot be done. So this gives you a view, overall view below the ground, a panoramic view below the ground, where the equipments are useful. This is another ground engineering spectrum which I have made many years ago, but it shows the total range of geotechnical activities in ground engineering. I call it ground engineering spectrum. The one here is the pile foundations. On the left is the green is completely pile foundations. Then I'll read only the headings: earth retaining systems, ground improvement methods, tunneling, dams, soil investigation and soil sampling, special methods, geotechnical software. That's again Indian software and is actually not there, but it's out of the subject. So if you look at the world market in deep foundations, you see that this is the percentage of how the ground engineering or deep foundation market is split. So you have 48% is pile foundations. So why not? It's going to be the same in India in the next 10 years. So we have ground improvement 10%, shallow foundations and so forth. So this is data from the survey made by Maurice from Frankie. So what about Indian market? Indian market in the coming years, it's huge. It's, all of you know, it's something like 5 trillion US dollars is going to be spent, and this is the breakup. Who's going to do it? Our contractors are going to do it. And we need equipment. All of them start with the groundworks. There's enough jobs in the market coming up, but I don't think we have enough equipment or enough contractors. And what's going to happen is, if we are not able to do it, projects will go on with or without Indian contractors and Indian equipment. This is the right time to pivot and change. And this kind of data is available everywhere, and we should take advantage. The younger generation should take advantage and move into this. Now, those of you who are not really in geotechnical engineering or soil mechanics, India is very diverse country, and it gives us a challenge plus an opportunity to see wide variety of soils in India. And without the basic knowledge of ground, I don't think manufacturers can succeed. So ground engineering, the profiles are available. We have enough knowledge in our universities and professors. We have all types of soils, almost all types of soils that are listed are available in some part of India. So this gives you an overview of how much you can try out so many things, and all the different types of soil profiles, and in the bearing soils, you need different types of methods of geotechnical, especially when you come to the bottom left, the earthquake map of India is again a big challenge for us. India is a very vulnerable, the earth is moving, and we have a great responsibility. The geotechnical engineers have a great responsibility to make our buildings safe, our infrastructure safe. So there's a huge opportunity, and knowledge of ground is very important. Another specific area where I think there's a great scope for equipment is the coastal profile of India. Uniquely, India has a great coastal profile, which is all habitable. I made a small calculation to see the index, which is the coastal index, which is the total length of the coastal area available by the landmass area. India comes out number 1 compared to China, US, and Russia. If you take the habitable areas only, Russia has got coastal areas which is just ice and nobody lives there. But India, the opportunity is 7,500 kilometers of coastal belt, and we have the highest coastal index. What does it mean? It means we have the challenge of attacking the coastal clays. We have soft clays mostly in coastal areas, and we need special methods and special type of engineering solutions and equipment. So this is something unique. I thought I should bring this point, that the Indian coastal line gives us an enormous opportunity and a huge challenge. Of course, I'm not taking this index small island nations like Singapore and so forth. I'm taking the large countries. Now, really, with that background data, let's go into the simple to the most complicated equipment used. So pardon me for some basics knowledge, basic information, which most of you may know, but for students, this is sponsored by the student chapter, they should know. The most common and the most prevalent use of an excavator is a bucket. Bucket is nothing but an attachment at the tip of the machine, which excavates with a downward force, and it takes the material out and loads into a truck. The most common, this is the most common, and the excavators can range from 10 tons or a weight to 120 tons. Similarly, the bucket here has a different capacities, maybe 5 to 6 cubic meters being the largest, and the weight depends on the weight of the density of the soil. This is the most common, and this is the most useful breakthrough we had about 25 years back when a company in India brought the first excavator. Now, the same excavator is being used for different applications with a different longer and boom and a longer arm. So this is called the boom, the portion here. is called the boom, and this portion here is called the arm. So with the longer boom and longer arm and simple moment calculation based on the counterweight, we can arrive at the bucket size, and this is being used for deeper digging. There's many applications, and this is longer booms and longer arms are also imported, and a few companies in India are making it. Very simple way to do it, but yes, it's useful now for deeper excavations. We're going for double basement, triple basements, so longer boom, longer arm are a great boom. So we also have deep excavations in all our metro stations and our cities having car parks and malls. So we see this kind of construction happening, and there's no way we can excavate into these pits without the excavators being lowered down. So we also use in the deep excavations these kind of small machines, 20-ton, 30-ton machines working in deep excavations. You will find them, but they get lowered through a ramp, and the most versatile machine. Then we have another special equipment which is called the Tele Depot. Now this Tele Depot is being now introduced in metro stations in the top-down construction. This top-down construction is some of you may know, is you build the top slab, leave an opening, and you start excavating, go up to 30 meters or so, depending on the station height, and you use this equipment for removing the muck. So these kind of machines, all these pictures from India, the top three are pictures from India, and they are being used in metro stations. I have a short video, but I don't want to stop here because it takes some time to switch. The video shows the operation of these machines, and what this does is there is a telescopic dipper that goes inside, and there is a grab bucket here which grabs the material. Again, the telescope closes and the machine swings and brings it down. So this is a very simple equipment, and even this is not manufactured in India. So, but it makes it expensive if you import and bring it to the site. But with the amount of metro work going on, these machines will find a great boom. Then we also have the simple attachments for our they call trenching buckets. This is just the attachment. For those students, I'm talking about this kind of shaped attachments. So this shaped attachments gives the shape of the canals as small drains, ditches, which is used on the sides of the roads, or which is used for agriculture or laying pipeline. So it gives the shape of the and makes it easy so that you can just put a concrete lining or some sort of lining and close the ditch. So even these simple things we don't see much in India. Now we go to the next large chapter called ground improvement. So ground improvement comes when we have the soil conditions such that your geotechnical consultant will say this is not fit because it is the soil is not good, so we have to do something to make it strong. Especially when I told you the coastal belts, we have 7,500 kilometers of coast, and at least 50 kilometers from the sea face, from the seafront, you have these kind of problems as the coastal soils. What you see here are various types of ground improvement. So one you call as a ground improvement, then the ground treatment, and ground reinforcement. These are three broad categories. Many lectures have happened on this, so I'm not going to dwell on the technology of this, but you can see what is highlighted in blue. All of them depend on excavator-based technologies. Without the base machine of an excavator, or a tracked machine as we call it, you could not do this those ground improvement like deep compaction, surface compaction, soil cement mixing, deep soil mixing, and so forth, stone columns. Without the base equipment being a tracked machine, you cannot get into this kind of technology. So if the vice versa, 20 years back, these were not popular because there were no equipment. Now, some innovative contractors are bringing this equipment or making it themselves in India, and we have projects going on. In the future, we're going to have more of this. This is a very famous chart. where it shows on the x-axis you will find the types of soil by grain size, and then the various techniques and the range of techniques we can use. So this only shows one technique cannot fit all, and one technique, like for example PVD, which is prefabricated vertical drains, which is very popular for consolidation of soft clays, cannot go when the particle size becomes large. There are other techniques. You can come down and look at other techniques. This is just a chart for the students and a guide for field contractors. So if you put earthquake into this and say which are the liquefaction potential for these areas, so the most liquefiable soils come in this range of between 1 mm and 0.001 mm in the, and it's sand and gravel. So and also the moisture content that is not here. So we also need to look at liquefaction potential and treat the soils. And more than 60% of the landmass in India has been declared as earthquake prone. The latest codes and microzonization that's happening, it says that more than 60% of the landmass in India is prone to earthquake. So we must take cognizance of this when we design for the future. Now we come to the next simple attachments, like how we do the compaction. These are compaction using attachments like plates. We don't see this at all in our daily life. These are simple plate, hydraulic plates, vibratory plates attached to an excavator. They work by taking the hydraulics from the base. Each excavator, it is called a hydraulic excavator. The excavator has hydraulic pump, and a separate line is brought into here and fitted onto this. So there are a few manufacturers of this in India, but we need to make sure that this is available very easily. Maybe a good rental company can do this. So these vibratory plate compactors are extremely useful for large, and it's a multiple use of an excavator for large areas. This is a very special vibrator for pipeline, or any, if you fill a trench with a pipe, and backfilling on the sides of the pipe are very important. This is an innovation by a German company. I've never seen it in India. We also have the same concept, but as a roller. So we can attach a roller, vibratory roller. All of you have seen a roller on the road during road construction. If you drive through our highways, you will find the soil compactor and asphalt compactor, which is also a vibratory machine. But the same concept can be used on a sloped canals. This has been used extensively in Gujarat during the Narmada Canal, but not very popular in other parts of India. Very simple vibratory attachments, and these are made by Indian companies. So there is a lot of innovation that can be done, and we are capable of doing it. So these are used for how do you compact the slope otherwise? There are alternate methods are very cumbersome, and this is probably the fastest and cheapest method for any slope compaction. As you all know, we have seen so many canals that are being built by our government, but their sides are not compacted. There is a slope failure, and the lining slips. We see this every day where it's shown on newspapers. So it's very simple, and we should get into the, at least specifying for our canals and ponds, and or by using vibratory rollers. There's another way of in a ground improvement technology called dynamic compaction. This dynamic compaction is very unique, and this is for granular soils called rapid impact compactor. So this is a simple, it's not so simple attachment. It's like a piling hammer attached to an excavator. So this portion is the excavator, and this is the piling hammer. This is a normal hydraulic piling hammer, which is 7 ton, 9 ton, 5 ton drop weight, using hydraulics to lift and the gravity to drop. What this company has done is simply make a large pad, like a 1 meter dia steel plate pad with some attachments, with some cushioning attachments, it simply makes an impression on the ground and makes craters like this. So this dynamic compaction method has replaced the more dangerous way of compacting granular soils by dropping heavy weights from a crane. So this was that technique is still being used, but it's a more dangerous method than this. So this method of RIP is getting popular. I think there was only one job in India, to my knowledge, where this equipment is used or at least discussed. So you can see this can be used in urban areas, in normal roads and living areas. It's a granular soil, but this machine, it has a terrific impact. You come and make these craters, and then it's immediately backfilled, and it's coming around a second time. And they all have design principles. The pattern of this impact, it's like a large impact. I'm talking about the impact force of more than 10 tons falling over 2-3 meters, and this is a continuously moving machine. It's called RIC. You can Google and see. The next more common and more accepted method is the PVD. This is for soft clays. This is for granular soils. This is for soft clays. So this is nothing but squeezing the water out. There are so many methods this can be done, and this is imagine a clay mass, a mass of clay with water with very low permeability. You want to squeeze the water out by surcharge or some method. PVD gives the path for the water to come out. So you install this with a special equipment. So the equipment is what I'm going to talk about, and leave this PVD, that is, there's a vertical drains, small drain paths, small pathways where water can be squeezed from the bottom. Why it is squeezed? Because you're preloading it, and or its own self weight if it's really soft. And there are many improvements to this. They apply vacuum also to get the water up, and this is pushed up, and then there is a drain blanket here. Water is drained out. So slow process. It's being used in large airfields and large areas where the area is very large. PVD is very commonly used in India and other places. So the PVD is more explained here. It is just a cross section of a small band, which is about 100 or 150 mm wide. It has got a geotextile outside, and then it has got pathway to water to come up. So it's a very simple system, but installed by machines like this. So these machines are base machines, are the same excavators. This attachment is what makes it called a PVD machine. This is a vibrator at the top. It vibrates and pushes this into the ground. I told you it's soft soil, so you don't need much of an energy to do it. And it takes along the PVD roll inside. The PVD roll is also taken to the bottom, and this is extracted. You will find this in many coastal projects in India. So this requires a basic 30, 40 tons or 50 tons weight, depending on the length and the weight of the system. As you can see in this machine, what has been removed is the arm. It's directly connected to the boom, and a vibrator at the top enables it to go down. So these kind of machines are very popular. As you realize, these are systems that are conceived in the research institutes and laboratories, but out in the field you need equipment. Without the equipment, these technologies will stay in the universities. The next method is Vibro flotation. Again, a ground improvement method is to introduce a vibrator. Imagine a long vibrator, which is into the like a concrete vibrator. It's a long needle pushed into the ground by itself, it sinks, or with the assistance of water jetting, and then it is backfilled with a granular material like stones or stones and boulders, or not really boulders, maybe 40 mm to 100 mm broken stone is filled inside, and this technique has been around in India for the last 25 years at least. We also have design methods for all of them. You need, without equipment, Vibro flotation is not possible. You have two systems. One is the top feed as the bottom feed. Top feed is the material is kept on the side, the vibrator is pushed inside, and the material here. There are a lot of seminars and webinars going on the technique, on the theory of this, but I'm just explaining the simple way how the stones are replacing the weak soils. And so it involves a vibrator, hydraulic vibrator. The bottom feed is you use the same system, similar concept, but you feed it from the bottom. There's a trap door here where the material is fed from the top with a hopper, and while it is pulled and vibrated, material fills in the bottom. Each technique has its own merits and demerits. This is the equipment, and we don't have to get into large equipment for this. We can go for the small excavators up to 30-40 tons in India, and we will solve most of the problems we have. And stone columns are very good way to design in earthquake-prone zones, especially liquefaction potential can be mitigated. Few stone columns of based on an excavator, even 20 tons. So this is top, and some of them are bottom. So these simple machines can easily be fabricated in India. We have the base machines. It's only and the demand is huge. Demand can be huge if the equipments are made available. And there has been a lot of innovation in the same techniques in Western countries. This is a system from a company, Geopia, from the Western world. I borrowed these pictures, and you can see they combine the hammering instead of vibro. They use a hammer technology. You hammer the pile and make the surroundings like a driven pile, and then fill it back with aggregates and so forth. They have patented system of hammer, edge. So these kind of things, the hard topsoil is hard, it's auger, then hammered, and then backfilled with granular material. All variations are smaller stone columns. And where do you use them? You can use them in so many locations in India, and very apt. It's also being used to strengthen railways. Railways, this is a picture from Germany, where the railways in between the sleepers, they are doing the same stone columns, the Geopia columns. A short video, I hope it works. Can you see the video?
For thousands of years, builders have used an old technique called over-excavation and replacement to address the problem of placing buildings on weak and compressible soils. The process entails excavating and removing a large volume of poor soil where the structure or footing would bear, replacing it with stronger materials, usually 7 to 30 feet. Layers of aggregate are then introduced into the cavity in thin lifts of about 1 foot in thickness. A proprietary and patented beveled tamper rams each layer of aggregate using vertical impact ramming energy. This pre-stresses and pre-strains the aggregate at the bottom of the cavity while forming a bottom bulb. Then, thin lifts are incrementally placed and rammed until the pier is constructed. The result is superior strength and stiffness. For sites with soils that are unstable during drilling or with soils that are contaminated, GeoPier Foundation Company has developed the Impact System, another proprietary and patented rammed aggregate pier method. The Impact System is cost-effective for installations in soils subject to caving, like saturated sand. The key to...
I will stop here. Just to give you an idea of that, these are all, they use a hydraulic hammer. This hydraulic hammer is the same hammer that we call as a hydraulic breaker. We sell close to, in India itself, 5,000 of these units every year, but it goes to a different type of segment. The same hammer is used in geotechnical field. So, and what you see on the left here is the strengthening with stone columns of an existing railway line. So it is only for the designers to innovate. Here I borrowed this from Huskers, Germany. These slides, this is also ground improvement. They call it the Ringtrack geotextile encased stone columns. So what this is exactly the same as what I told you earlier, but the whole thing is encased in a SOX type of a material, if I may. So geotextile tube, a tube of this size, large size, and this is installed by machines. It is drilled, it is vibrated into the ground by a vibrator, a pipe with a closed end, and then the SOX or the geotextile tube is introduced, and it is filled with sand and withdrawn. This is for extremely soft clays. I acknowledge the slides from Huskers, and these are extremely soft clays that are very, very soft. So you can see the unconfined strengths are extremely low on the right side. This is another system being used for, can be used in very soft soils. So this is Huskers method where, as I told you, a tube with the bottom closed is vibrated in with a vibratory hammer, and once it reaches the ground level, it is filled with a SOX type of a geotextile tube is introduced and filled with sand. The next method is shallow soil mixing. Soil mixing is another method of ground improvement where the clays which are, or the weak soils, can be strengthened by addition of a suitable third material. It could be cement, it could be lime, it could be specialized chemicals, and so forth. Now this has gained a lot of importance in the world, and deep soil mixing and shallow soil mixing are being used for treating soils which are weak and would have been originally rejected as a favorable site. How can they be used? They can use in blocks or grids, or make it wall for temporary excavation, or load-bearing columns. Today we have standards which can be adopted, and Western world has started using this, and in India we don't see much of this. The same methodology can be used, same principles can be used for contaminated soils. So shallow soil mixing, use an excavator. The whole mass is mixed. It can be mixed dry, or it can be mixed wet. So it's a very cost-effective solution. And when I say shallow, we can go up to 3 to 5 meters or 5 to 7 meters. Then we go to deep mixing. Shallow soil mixing is made with excavators and replaced, and you have a plant which can pump from the bottom down, and we have mixing methods, special mixing methods. So one of the easiest way to mix the chemicals or the cement is using excavator-based drum cutters. These drum cutters are used as with a special type of blades for mixing, for proper mixing in below the ground. So a short video. You see here the shallow mixing. The machine is used with an attachment called drum cutter, and then the whole area is rolled with vibratory compactor. You can also go for specialized systems. There's a company called Alu in Finland. They have this system called specialized mixing, and they have a whole train of pressurized dry mixing. The question is, how, if you change the moisture content of already soft clays, you cannot, you're weakening the soil. So these company has a dry mixing with a pressurized chamber, and the mix is pushed to the ground. As you can see, you under the railway lines, on a working railway line also it's being done. So this is so this is very, very common in Europe, not popular in India, and soil mixing is going to be a future of India. Next is deep soil mixing. So we talked about soil shallow mixing. Now it's a deep mixing, again excavator-based machines. See, these excavators are slightly modified for its stability from a standard machine. When we say deep, we don't go very deep. there are specialized machines for that. We can go up to 20 meters with the standard machines. And we have this kind of a mixing probe where the hydraulically this is pushed into the ground, and there are mixing paddles and the ejector and holes here, and the slurry is pumped inside. There's so many applications of this, temporary walls, strengthening of soils, and so forth. So the principle of deep soil mixing is quite clear. You can make a series of penetrations, and while the auger is rotating, the mix is pumped inside, and the auger is withdrawn, and it mixes with the soil and makes a column, a stronger material. So these columns look like this when it's excavated. They are load-bearing columns, and I borrowed this from Howard Baker. Thank you. So you can build it as soil cement retaining walls. You don't have to build very strong piles. You can make these walls. You can design these walls, load-bearing columns, and embankment support piles. In the excavator, they look like this. This is a trench cutter attachment. It's a much bigger machine, but you can see the kind of columns being built with soil cement. Sand piles are very commonly used for either load bearing or for drainage in soft clays. And these are could be many ways. You can use a driven piling system with a sacrificial shoe, and the pipe is withdrawn after filling with sand. Introducing sand piles have been there for a long time. Again, you use this machine. This is one of the latest things I have found out. This company in New Zealand has driving timber piles in very, very soft clays. These timber piles are driven by a vibratory system, vibratory hammer, and they are driven in extremely soft clays, and they consolidate. The theory is it also replaces the PVD train, the time required for consolidation during PVD train, because the piles themselves act as a load-bearing member. So this is one of the latest things I've learned recently. Now come to another system where we are totally, India is missing on this. If a common man wants to drill a hole in the ground, we do not have the right equipment. I call it the Indian jugaad, because they are not meant for this. These equipments are not sold as a drilling equipment. They're used as a drilling equipment in a very innovative way. These are companies in India which make it, but we can. The problem of drilling holes, it can be a 150 mm or it can be a 1 meter diameter hole, is a work of a hydraulic equipment. Here, this is using the PTO of a tractor. Nothing wrong, but this how deep can go with this kind of equipment. This is used a very good way to use for crash barriers. So these, I would say, I'm calling it the Indian jugaad because you don't see much of this in Western countries. What you need is the hydraulic drilling auger like this, which can be used with a backhoe loader. Here you see with a backhoe loader, hydraulic auger is very simple way to drill holes. You can drill holes up to very large size. It all depends on the torque, and the torque depends on the motor here inside, and then the hydraulic power of the machine. So this is a very good way to give to our public way to drill holes using a hydraulic auger drive, we call it. It can also drill through rock. This is from Qatar, where it drilled through very hard rock by changing the bit. Same system. Now we come to a very one of my favorite topics, the underrim piles. So why I put the picture here is, those of you can recognize, it's Professor Dinesh Mohan, who was the director of CBRI, who I would say invented this piling system. He invented this piling system for India way back in the 70s. And he did what today's academicians don't do. He invented the system applicable for the black cotton soils of India. And he also devised a simple equipment to execute it, and had a company in the same Roorkee, where CBRI is located, to distribute it across the country. And he brought out this book from CBRI, handbook, which I still have, which became the Indian code, IS 2911, at a later date. This is the complete journey I owe to this man, and my BTech thesis was on undering piles, 76. So I really honor a person like this from the academia to bring this to the field and make the right equipment and convert it to a code of practice. Today, it's been used across India, but the only problem is it is done 50 years ago and there was no mechanization. This was what Professor Dinesh Mohan invented. I'm using the word invented because nobody else did it before. And this is highly labor intensive method, a simple tripod rig. But even today, there are thousands of these contractors across India using the same system. My question to the manufacturers is why this has not been mechanized and why this 50-year-old equipment is still being used. Sometimes it is, we feel ashamed. I feel ashamed to show these pictures in international conferences. But are there solutions? Yes, there are solutions. So the belt piers, which you see on the left here, it's been there for a very long time. Belt piers were used in the Sears Tower in the 70s. So very large diameter piles can be done with an under ream. Simple tooling can be done. You can see the size of equipments being used. So these kind of small equipment with augers, which can go from down up, and the belling tool here. So it's all, everything is possible. The connect has not happened. You can see the diameter of this under ream pile. It's more than 1 meter diameter and with a bulb of more than 2.5 meters and the length of 9 meters. So under ream piles can fantastically replace so many types of piles in India, especially in the black cotton soils and expansive soils in our country. We need mechanization. So this is an innovation done in China for a similar type of equipment, completely hydraulic, using a hydraulic equipment. So this equipment uses the hydraulics to make the bulb. Such systems should come into India in a large way on base machines, 20-ton machines. Now we go to the next method, which is the drop hammer. We have been using piling hammers for a very long time in India. It started with the Hiley's formula of drop hammers, and we still have a lot of driven piling being done, though the testing and the design methods have changed. But why don't we have small drop hammers on most popular weight, which is 20-ton piling rigs? These are very simple attachments. They can be made in India, and we can go for short piles. We can go for piles up to 10 meters using drop hammers. You can go for precast piles using drop hammers. So these are all the things that can be easily done from our equipment point of view. Then we have the excavator mounted excavator hammers driving pipe piles and sheet piles. We don't see much of this also. Very simple way this can be done. Then we have another equipment called the low headroom. Sometimes we need equipment which has a low headroom to work under inside a building or under a railway line, under a power line, and so forth. So there are low headroom piling rigs also in the market. This is another very, very innovative method which is not available in India. This is use of a standard hydraulic breaker. I showed you one earlier. There's another method. The standard hydraulic breaker is being used to drive piles, steel pipe piles. So everybody knows a standard hydraulic breaker. I told you we sell about 5,000 a year, and this can be used. It's a very simple innovation and very easy to do. As you see, it's being done inside a factory. So this is one of the low headroom technologies. Very simple to adapt. Again, low headroom pile driving hammers. These hammers are imported. So we should start making them on very small equipment. The equipment size can be even 7-8 tons to drive these piles. Now, because we don't, in my opinion, because we don't have these small piling equipment, we have to go for very large piling machines, hydraulic piling rigs. We have got a new class of machines called the tractor piling rigs, which are proving to be detrimental to the industry. Many jobs recently, my colleagues in the deep foundation industry know about this, are failing because they have extended the water well boring rigs into piling. This should stop. And in my opinion, there is no IS code to which is allowing this also. So you will have this kind of intrusions into their deep foundation industry. Another method is called the CFA, or the auger piles, or the continuous flight augers, CFA. These are long screws, screw piles, screws that are into the ground, and then concrete is pumped inside and withdrawn. The method of driving the screw inside could be a hydraulic motor, or it could be a small mast here with a leader. We call it a leader. All these are attachments to make the spiral hole inside, and concrete is pumped into it while it is withdrawn. CFA is just made an entry into India, and this has a great future. Micropiles. Now we go into a sector where micropiles, mini piles, and soil nailing. These are all attachments to excavators or backhoe loaders. All this is possible provided we recognize that these are simple attachments, can be made by our industry. The main problem is the industry don't know the demand and the specifications of what we want. So this company, for example, in the US, TEC, makes only attachments for mini piling, soil nailing, micropiling industry. The next is helical screw piles. It's another favorite subject of mine, is introducing metal screw piles in the ground and leaving it in place permanently. There's so many advantages, and it is yet to come into the country. I'm trying to spearhead this entry through DFI. So helical screw piles are long metal screws that are set in the ground and using hydraulic drive. So helical screw piles can be used for retrofitting on a sinking building. It can be used under a railway line for strengthening or a pole. There are so many uses we can do in existing situations. I have a short video of the helical screw piles, not run just for people who don't know the concept.
As you know, it's important as you're installing here.
So what you see here is a 6-inch or 150 mm diameter helical screw pile being driven into the ground. And this this helical screw pile, the concept is the metal section is left into the ground, and this becomes the load-bearing pile. The helical screw piles are, you see, no spoil comes out of the ground. The design methods are available. There are manufacturers doing it. In fact, there are manufacturers in India who make for countries like Canada and Australia, but no, there's no demand in India for this. Again, this is an excavator-based technology, and this can be used, helical screw piles can be used. So it can be installed very easily using hydraulic drive. Here you see a bobcat driving it. Very small equipment also can be used. Helical screw piles has enormous usage. The segments of use could be very large. A few I've shown here. Solar is one of the best applications of our solar panels. India is launching on solar, building retrofit, pipeline work, building foundations, and boardwalks. So many places we can use helical screw piles. Then we have the low headroom rigs. I mentioned a few, but these are examples of a low headroom rig. This is I borrowed from an American company, and you see under transmission lines, under bridges. This is being used in India. A few companies have these machines, but low headroom rigs can be used only with an excavator. The most common attachment comes to rock breaking methods. Now I'm going to discuss rock removal methods. I'll not dwell so much on it. All of you know about this. hydraulic breaker, which is an attachment, most common attachment in India for the quarries and mines. So video. Another rock removal method is the hydro ripper. We have used this. We have started using this in India. This is in Barmer in Rajasthan. This picture on the bottom right. There are many applications for rock removal using vibratory ripper or an ordinary ripper. So this is you can use it as an ordinary ripper. Like this is an ordinary ripper, no vibration. This is a vibratory ripper. Unfortunately, for a lot of time, I'll skip the videos. Then you have another attachment for rock handling is the trencher, drum cutter or trencher, where you have used you can go up to 150 megapascal rock strength and make trenches right in the rock. You can do the cross country. This is in Raigad. These are other locations. Some of them are not in India. It comes in wheels. It has a chain. So many different ways you can drill through, make trenches in the rock. Making trench is also part of ground engineering. The same concept can be used for underwater, and this has been used in India. And I'm proud to say one of the attachments is made by an Indian company with an imported trenching attachment. So this can be used for underwater trenching of canals, of deepening canals in ports, underwater works, and so forth. This is these off the coast of Gujarat, the underwater trenching for a pipeline. Next, we have the drum cutter itself can be used for rock excavation and tunneling. So this method of tunneling and excavation of hard rock, mining and hard rock, we are getting into. This is in a cement mine in Jammu and Kashmir. This is for sandstone in Germany and so forth. These again in India. So these are being used, and these are all excavator mounted machines. Then we have I'm trying to rush. Then we have machines that are splitting the rock in tunneling. And this equipment, this is Chennai Airport. Rock is being removed in the expansion to Chennai Airport using rock splitter. This kind of rock splitters, specialized rock splitters, are being used in tunneling in India too. This machine has been used in Bangalore Metro. So these are all using the power of excavator hydraulics. Then we have the high impact hammers. I'm skipping the video. Is a very high impact. One blow breaks a stone. It may be interesting. So one single blow is enough to make a bolt, to break the boulder, and that kind of impact is used instead of using a hydraulic breaker. There it goes. Now we come to soft rock removal. So if you have soft rock, in tunneling, especially soft rock, here you see the Subansiri tunnel, where my company has done the soft ground tunneling in the tunnel in the hydroelectric project using drum cutters, and the limitation is the strength of the rock. Then we come diaphragm wall construction is now getting very popular because of the metro rail projects, and these are all base equipment modified to have the diaphragm walling attachment. So this is nothing. Right now we are importing all these machines at a great expense, and it pushes the cost of the work also. So this is a small diaphragm walling machine for grab with a diaphragm walling grab, rope operated grab, up to 15 meters. We have basements coming up. We can use these small machines. Next, we have the Vibro sheet piling and a vibratory hammer to drive the piles and the pipes. Very common Western world, slowly getting common in India. So this is from L&T's side with a side grip hammer. So this machine holds the equipment on its side. These are vibrators at the top and push down. and this pushing a pipe. So it can push pipe or sheet piles. So many of these attachments are possible. Unfortunately, we don't have manufacturers of this in India. With the expanse of the metros, there'll be a huge demand for the excavators as well as the attachments. Video, I'll skip the video, please. Then we come to earth retention systems or earth retaining systems. So these are all soil nails, soil nailing we call it, or tiebacks, or so many names, screw piles, so many ways we can retain this earth in slopes. Especially in our Himalayan ranges, we have a lot of slope failures, and in our mountains due to deforestation. So the soil nailing system is being used for excavation and the slope retention. All these are all excavator based, as you can see, for installing the soil nails. You must excuse me, I'm trying to push. We are on the 88th slide. We have 12 slides more. Then we have the long boom river training works. Government of India has an ambitious plan for the interconnecting of the rivers and Sagar Mala project. So all these will require working on the river, or I call it river training works. These river training works will require long boom, long arm machines, either working on a pontoon or working on an amphibious condition. Here you see this machines mounted on a barge, on a pontoon, on a jack-up, semi-jack-up, and is probably deepening the sludge, or deepening or removing the sludge, and so forth. A short video, this is from Cochin, from one of our customers. So what they are doing is dredging the riverway and removing the muck using a bucket. Just to show you that this long boom, long arm was made in India and an Indian contractor. But these are special machines today. And these kind of long boom, long arm machines are used in river training works, in river protection works, and so forth. I think this is a video from another contracting company in India, putting the stones in the right place for shore protection in one of their projects for shore protection. So you're using a long boom, long arm, and a grab, stones are placed. So these are all techniques being used in India, and you will find more use in the coming years. The other is the amphibious excavators. These are excavators can be used on ash ponds. This can be used on river training works, and they're modified. A normal excavator modified with instead of the normal tracks, it is changed into a amphibious track with a pump. Some of them come with a sludge pump fitted. You can fit a sludge pump, or you can fit a bucket. All these are slowly coming into the country, but enormous scope available. So this has come with a sludge pump pumping out the mud. This is an ash pond waterway. This is a pump in the front. Usually it is pumped into a barge. You see the line going in. It is pumped into a barge. Here you see another long boom, long arm machine with a pump, and then the spoil is pumped into a barge. So they are all pictures from India. Then we come to the blast hole drilling. Blast hole drilling for mining and geotechnical field. If you want to remove rock, these are all attachments available on excavators or blast hole drilling. Then the pipeline works. India has a very ambitious plan to build cross-country pipelines, LNG or LNG lines, and to supply gas to our homes. So there are specialized equipment available to handle these pipes. This is called the pipe layer, which is an excavator-based machine. And these are pipe handling grabs, vacuum grabs for handling the coated pipes. These are coated pipes, and it should not get spoiled. They use special grabs. These are vacuum attachments to concrete pipes. So this is all mostly not seen much in India, though some companies in pipeline work are using. Then you also have the backfilling. Once you do the pipeline work, you need the backfilling, and you have some specialized buckets. There's a video. So these simple buckets are all good for backfilling the trenches, and it removes the large size particles. It retains the large size particles and puts it directly into the trench. Then we have also another equipment which is getting popular after doing the piling in our metros, in our large projects. To break the piles, we have pile crushers. These are equipment that are very good, very productive. Slowly we're getting the use of this in India too. Then we have the diaphragm wall crusher. We have diaphragm wall crusher, which breaks the diaphragm walls for metro projects. We also have a sawing concrete for concrete piles, a machine that can cut off the excess height after driving, and it grabs it and removes it. These are all very new inventions in the world. As you can see in this picture, it is grabbing the top portion of the pile. It has cut from here, and then it has got a diamond blade to cut, and this is removed and taken away. The last of the applications is, would you think the concrete vibrator can be attached for large dam projects, for large rafts? Though it's not really geotechnical, but rafts and dams are designed by us, geotechnical engineers. These are hydraulic vibrators used for compaction of concrete. And we don't see much of this also, except in remote dam projects. This could be very good for our rafts in multi-story buildings. Our high-rise buildings are going taller. Rafts are almost 3-4 meters deep in Mumbai and other places. So we should start using effective vibrators like this. So I've come to the conclusion slide. There are lots of opportunities ahead for selling heavy earth moving machines with suitable attachments to existing and new entrants. We need new entrants. We need more players in ground engineering. There is a constant need to innovate in ground engineering. Unlike other trades, we need to innovate if you want to sustain. I feel the time is right for the manufacturers to enter the ground engineering applications. R&D and prototype should be supported by academia. Academia have got a great role to play. More young qualified engineers should take to contracting and ground engineering. Indian demand in ground engineering applications is bound to increase, and all Indian manufacturers are in an advantageous position to participate in this growth. Lastly, as our Prime Minister says, make in India and make for the world, and Atma Nibar's the program will support all of you. And I want to say that as an executive committee member of DFI, we are going to have 3 webinars and a big conference, virtual conference. Please make note of the date, and this will cover some of the best technologists and academia professors are going to be in this webinar. For example, the foundation design engineer for Burj Khalifa, world's tallest building, is going to be there, and many more. Please note the website and you can go on it. I suppose it's okay because it's supported by DFI and IGS and IIT Madras. I can play the slide again. Lastly, whatever I have learned, I owe to my gurus, my mentors, and my alma maters. Some of you will recognize this is Professor Ralph Peck, who was in my university in the US. This is Carl Terzaghi, who is the father of soil mechanics. This is Tom Davison, my advisor in United States. I did my engineering postgraduate. This is Professor Ireland, who is still living. This is Ben Felinius, who is going to conduct one of the talks in the webinar coming up of DFI. This is Professor Dinesh Mohan of CBRI. And last but not the least, my father, who is my mentor. Thank you very much. And there ends my lecture. Mr. Amara.
Thank you, sir. Before going for the question and answer section, I am sharing the Google form link for feedback.
Should I stop sharing or keep it?
I'm sharing, sir. The chart. Okay. The chart. I'm sharing the feedback.
No. Should I stop sharing and see the chats?
After sharing, there is a question and answer section, sir.
I will keep my share because if there is a question, I mean, there is a question from a slide, I can go back to the slide, okay? I'll keep my share on.
I shared the Google form link, so you can share your questions in chat.
Are there any questions coming up?
Yes, sir. Some questions are coming in chat, sir.
Oh, I'm not able to see that.
Hello, sir. Sir, the questions are available in chat, sir.
Yeah, I see the chat, but I don't see any questions in that. Only so there is one question here. Amal Bhattacharya, we have started bidirectional, it's not biodirectional, bidirectional test for a large vertical static load test, OCL, as per IRC 78. Do we have instrumentation for similarly lateral toasters for large diameter? Any agency equipment Figuro has been able to confirm? Figuro has not been able to confirm for lateral test any other agency. I would suggest you contact Pile Dynamics, who have two representatives in India, and Mr. Rajesh Vaidya is an expert in this field. Please contact Pile Dynamics. So there's a question from So Ravi Bachali, Ravindra, my question is, most of these machines are possible to design and produce in India, but even a prototype is expensive to make. How can academia help? Yeah, any stage of production will be a prototype, then a pilot, 1 or 2 pilots, then only you get into production. Yeah, there must be an investment for R&D in this. Academia cannot help you here. They can help you in your design, but they cannot help monetarily, in my opinion. But I think it's good to approach the government. They will have some funds for R&D. I'm not aware of that procedure. Equipment manufacturers will be able to answer. Can we see CFA piles execution with excavator based on continuous survey? If yes, what are their applicability? Yeah, I'm missing it. Okay. CFA piles are excavator based machines, and excavator by augers are available. I think Sunil Basarkar is here and he'll be able to answer, but this is something, attachments to excavators for making CFA piles, not very long piles, are available in the market. It can be also made in India. Experience of failures in excavation is shared. Now this is not the forum for it, sorry. Any manufacturers of jet grouting attachments and manufacturers of attachments in India? Rambabu, hello Mr. Rambabu. So to my knowledge, there is no, there are manufacturers of hydraulic machines, pumps that can pump jet grout inside. But somebody who's, I don't know of anybody who's manufacturing and advertising. There are individual contractors who have made it for themselves. But there is no brand available for jet grouting equipment as an attachment to an excavator. How do you foresee usage of these machines in India in this pandemic situation? No, I think it's pandemic situation is a temporary pause. It's a pause button. I think it will open up, but the projects are still going on. We have to make all the precautions and go on. But a pandemic situation may not affect too much. It'll be too much, but the normalcy will come. Wait for the normalcy. So Dr. KSR has replied that WorldCon Technologies, Ashutosh Ghosh, I think he's joined here. He is got the attachment for CFA on excavators. Do you have numbers, volumes to support need for these special machines? I don't have the numbers, but the demand can be predicted and the numbers can be worked out. But if we ask for authentic numbers, it's a catch-22 situation, chicken or egg. So if it's available, then people will start using more of these equipment. I said 1% of the machines can be converted into ground engineering. So that could be a number you can take. So this is a question to IGS Guntur. Based on today's event, whether IGS Guntur chapter can take lead 1 or 2 technologies suiting to AP in the next 2-3 years. I think Dr. Saramara should. The ideal way, which I thought it will work out, is we have so many good institutions with so many professors with a lot of knowledge and lab facilities. All these have been created for a purpose. If each of these technologies can be taken by one of the NITs or IITs as their research project with the industry, then we can make some headway on this. If everybody talking about everything will not work. So this has to be this has to be taken in a different forum and then allotted by the government to the NITs and IITs as a R&D project. Unfortunately, we do not, unlike mechanical engineering, CSIR does, like Merado, which is the wing of CSIR, we do not have in civil engineering except SCRC and CBRI. CSIR does not have a laboratory to bring out construction equipment along with research. It's my opinion. I'm not sure about it. I think so. WorldCon, yes, there are, other than WorldCon is one of them. There are others too who can, with these kind of auger attachments. So Bimal Roy has asked, how about these attachments explained here are available or manufactured? This is exactly the purpose of this lecture. Because it's not available, I'm telling you that this should get into the attention of manufacturers. Either by collaboration or by independent research, this can be made in India. They are not rocket science. Anybody using shallow mixing methods in India with excavator attachment? Any projects in India, deep soil mixing done? Yes, there are references and can be used. I think anybody should be somebody to start with. These are simple technologies, and we can support somebody who comes in. See, it's a chicken and egg situation. We have to start somewhere. IGS Guntur chapter can take mass shallow soil stabilization as a project. Yes, yeah, they are in a IGS Guntur. They are located in a situation is where the soil is expensive clays, and they can definitely try it, start using it to trial stretches. There are stretches, important stretches in and around Chennai where I live, where these treacherous soils are available, and trial stretches must be done in conjunction with the trial projects must be done before we launch it nationwide. I think that's the end of the question, sir. Can we? Not many challenging questions. So WorldCon, Ashutosh Ghosh says they are offering solutions. They're one of the companies they're offering, but I wish we have companies who make in India because it's expensive, it's prohibitively expensive to have attachments which are so expensive, sometimes costlier than the base machine. This is where the price barrier comes in specifying these machines or people to buy these machines. So ideally, in my experience, these attachments should not exceed the 50% cost of the base machine. If they're made in India, it's possible, but it's just a thumb rule. It depends on the machine itself. Attachment. Professor Ramarao Garu, I think that.
Sorry,
Yeah,
I think Ramarao is in meeting, sir.
No, if there are no more questions, should we wait or?
I think no more questions are there. On behalf of Dr. Ramarao, thank you, sir, for giving the extra expert to this technology.
Okay, thank you, everybody. I'm closing my meeting. Thank you. Thanks a lot. Thank you very much.